Hello, today we're going to talk about linear first-order constant coefficient DEs. So these are DEs of the form AX prime plus BX equals f of t. First order because there's only one derivative. Constant coefficient because the coefficients of x and x prime, a and b, are constants. There, I'll just abbreviate constant like that. Let's be clear what we're trying to do here. F of t will always be some known function, like e to the 2t or cosine of t. And to solve the equation means to find the unknown function x of t. Now, let's give this equation a name. I'm going to call it I. And before solving some specific examples of I, I'm going to talk about a general principle called the superposition principle. Superposition is just a fancy word that means adding two functions together. And what does the superposition principle say? It says, suppose that xp is a solution to the equation I. So that means, I'll write it out explicitly, it means that axp prime plus bxp is f of t. So I can draw an arrow there, like that. And we have to make one more assumption. And x sub h is a homogeneous solution. Or I should say a solution to the homogeneous equation. The homogeneous equation is our dE, ax, in this case h prime, plus bxh. But instead of having f of t, it's homogeneous because we put a 0 there. So I can put an h there for homogeneous. Then the principle says, then x equals xp plus xh is a solution to I. Why is it called the superposition principle? Because I've superpositioned xp and xh. That is, I've added them together. And this says if I start with a solution to I and I add a homogeneous solution, I still have a solution to I. Let's prove this. So in order to prove it, we have to substitute x back into I and see that the equation holds. That is to say, we want to know that ax prime plus bx equals f. Well, I don't know that yet, so I'll put a question mark over the equal sign. Well, when I substitute it in, what I have is a times, well, x prime, x is xp plus xh, so that's just xp prime plus xh prime, and then plus b times xp plus xh equals, and as we're still questioning it, our f. Well, let's pull this apart. I have an a times xp prime plus a b times xp. There's an xp prime, there's a b times xp. I also have an a times xh prime from over here on the left, and a b times xh. And we're still hoping that that's going to be f. But now what can we do? Let's look at this pair right here, ax prime plus bxp, and see what that equals. We know what that equals. We made the assumption up here that it equals f of t, so I can replace that by f of t. And what about this axh prime plus bxh? Well, over here we made the assumption that that was a homogeneous solution, that is to say it was 0. So now I have that f equals f. So I've proved the superposition principle. Now we'll take this and we'll apply it to solving a specific case of a first-order linear constant coefficient dE. Okay, so now let's do a specific example of a first-order constant coefficient equation. Let's solve the equation x prime plus 4x equals 3. This is simple. We just put a constant function 3 on the right-hand side. Well, the superposition principle tells us we want to do this in two steps. First, we want to solve the homogeneous equation. X prime plus 4x equals 0. This is easy. This is just an equation. If I rewrite it, minus 4x, that's exponential decay, and we know the solution here. It's x sub h, h for homogeneous, is some constant times e to the minus 4t. You can always check this if you don't believe it. Differentiate xh and I get minus 4 times xh, which is exactly what the equation says. Okay, the second part, superposition, tells me to look for a particular solution. Our strategy for particular solutions is almost always going to be the same. We're going to guess a solution of a certain form and then see where the algebra leads us. Since I have a constant on the right-hand side of my differential equation, I'm going to guess xp, p for particular, is a constant. Let's call the constant a. So what I'm officially doing is trying a solution. Well, after you try a solution, the next thing you do is you substitute. That's a formal way of saying you plug what you guessed into the original equation. So I need xp prime plus 4xp equals 3. And when I plug in my constant, the constant has derivative 0, plus 4 times a equals 3, or a equals 3/4. So I now have my particular solution. I only wanted one of them. X sub p equals 3/4. And now I can use the superposition principle. Superposition, there I'll abbreviate that too, says that my solution x is xp plus xh. I can superposition these particular and homogeneous solutions, and we have that's 3/4 plus c e to the minus 4t.